goes to this two different outputs.
Exactly, exactly. Not a function, absolutely not a function. Because in a function, the output that is assigned to an input has to be non-ambiguous. It would be very clear. It means for every input, I have to assign exactly one. And the word exactly, which is I put it here in red, is the crucial idea behind a function. It means I cannot assign two different output for the same input. There should be non-ambiguity. Ambiguity is not allowed when we talk about a function. So this is not a function. Not a function. Crucial, because the input of 2 is assigned because, sorry, we assign. Okay, I read because I messed up in the writing. Because we assign to the input of 2 different outputs. So there is ambiguity. That's not two different output. So that's not absolutely not a function. So for a function, we have to be very, very, very clear. Whenever I tell you what's assigned to 1, it should be 1 term. If you assign 2, that's not a function. There should be no ambiguity in the definition of a function. All right. Now, notation. And then I go back to the example. Notation. You know, as the input changes, right? So 1, 2, 3, 4, the input really changes. So sometimes we use symbols to represent any element of the input. So the idea that, suppose we use X as a symbol used for the elements of A. Okay, so A could be US citizen, A could be a bunch of numbers, A could be 4 numbers, so A could be anything. So if X is the symbol used for the element of A, it means X is the symbol for the input element. Then f of X, that's F, parenthesis X close, that's we read f of X represent the element that is assigned to X. So that's the notation we use. F of X has a name, is called the output that corresponds to the input X. Okay, so now we try to understand the notation. So if X is any element of A, f of X represents what we assign to A. So f of X is the output, it's what we assign to X. We give it a symbol, and the symbol is f of X. So it's a symbol for what we assign to X. Okay, now we go back to our example and see. Okay, so let's go back to this example where we have a function. Okay, are you guys done? You have to let me know before I change page. Okay.
You might leave it there for just a second.
Okay.
Thank you.
Done?
Yes, thank you.
Everybody, all right. So now let me take back to this example. This notation f of X. So here my input values, as I said, 1, 2, 3, 4. So when I write f of 1, parentheses, that's crucial. So what's inside the parentheses are the input value. F of 1 is what we assign to 1. It's the output we assign to 1. So in this particular problem, f of 1, what we assign to 1, is nothing more than the letter A. Okay, now, again, the same thing, f of 2. 2 is the input value. F of 2, this whole new symbol that we introduced, is the output that corresponds to 2, or what we assign to 2. What we're assigning to 2 is B. So that's really the notation. F of 3, again, f of 3 is assigned to B. So f of 3 is the symbol for what we assign to, and what goes inside the parentheses is 3. And finally, f of 4, in this particular example, is equal to C. Okay, so that's our the notation. And that's the definition of a function. Now, we're going to work with that. I'm going to give you a bunch of examples and try to work with functions. So example number 1, I will read it with you and I will expect your answer. All right. Number 1. I mean 2, 3, whatever. Example. I read it. Let A be the set of all US citizens. So already you have to have a picture. You have all the US citizens. And let F be the following group. It's the rule that is signed. So whenever you hear the word function, I have to talk about what does the function do, what kind of assignment it does, if it is a function. Let F be the rule that is signed to each person in A their telephone number. My question, is F a function? I want you to think a little bit. What are the input elements here? What are the output elements? Does every input have exactly one output? That's the way you answer the question. So I'll give you 1 more minute, either to write the problem, which is from the book actually, and to give me an answer. Think about it. Think about yourself. You are a US citizen, let us say. Ask yourself, okay, does the rule assign what to me? Very good. I'm having one very good answer. Okay. Who would like to speak up? Because very soon I'll start picking names. Who would like to answer? Matt Aquino, would you like to express your answer in?
Sure. It's not a function because. Wait, can you hear me? Hello?
Yeah, I can hear you very
Okay.
well.
It is not a function because not everyone has a phone number. So that means every input as a person does not have one output, which is a phone number.
Right. So he's going to give me one reason. So one is said not a function for the following. Because the definition of a function said, in the definition of a function, to each element of A, we can assign one element of B. So he's telling me, no, it's not a function because not every US citizen has a telephone number. So not a function. So we're going to have 2 reasons behind it. Not a function because not every input, means not every US citizen, not every input, which are the US citizen here, have an output. It means a phone number. There are some people who definitely don't want to have phone number. Okay, so one reason it's not a function, not every input have an output, which is exactly a phone number. Can anybody give me another reason why this cannot be a function also? So that's very good reason. Reason number 1. Is the output unique? Do you think? Suppose I pick a student, any student, or let me pick myself and myself. So I don't pick on anyone, normal. And I'm going to associate to Norma, that's what a function is. The rule tells me associate the phone number. Is there exactly one phone number associated to a person or more than one phone number? What do you think? Is it possible to have more than one phone number associated to every input? Anybody?
Yes, somebody could have more than one.
Right, I can have more than one. I can have, for example, my phone number, home number, my cell phone number, my work number, or I can have two cell phone numbers. So even the output itself is not unique in this scenario. So if you tell me, what's your phone number? I will look at you, I tell you, you know which one you want. You want my cell phone. You want my home number. So also the output is ambiguous unless we are very precise, which is hard in the case of a phone number to be precise. Okay, so two reasons this failed to be a function. First, not every input has an output. Not every person has a phone number. Another reason also it fails to be a function is that the output is not unique. A person, which is the input here, can have more than one output. We have home number, cell phone number, work number, and so on and so forth. So it definitely does not satisfy any of the conditions of a function. So not a function because that, or because every input is an input can have more than one output. It means a person can have more than one phone number. Okay, I read again. Because an input, which is a US citizen, can have more than one output. It means a US citizen can have more than one phone number. So this is not a function. Okay. Example number 2. Let F be the rule that assign to each US citizen the name of their biological mother. So what is this rule? It takes a US citizen, any person, these are my input value, and it assigns something to them. That's why it assigns name of biological mother. All right, is this a function? Yes or not?
Yes,
Yes, because
everyone comes from a mother and a father.
one mother. That's the way one. Because every person has, definitely yes, because every person have exactly one mom. Yes, because every person have exactly, that's the output, one biological mom. Okay, so now let us understand the notation one. So I'm gonna play a little bit with the notation. So all of us, I think, know Malia Obama, right? You all have heard of her. Equal to what? So I'm working with the same example. Okay,
Oh.
and my example is, that's a function. To every US citizen, the name of the biological mom. Finish my sentence. F of Malia Obama equal.
Michelle Obama?
Exactly. Exactly. That's what this function is. So Malia is the input. That's my US citizen. F of Malia is the output. It means what's the output? It's the name of the biological mom. So that's the notation. So F of it is the name of the biological mom. This is my input, and that's the output. Question number 2, I'm still working with the same example. Suppose I tell you, my name is Norma. By now, I hope you know. F of Norma, and my last name is Elias, equal Yvonne. It's the same example. Who would like to interpret this sentence to me, or this expression? What am I telling you here?
Yvonne is Norma's mom?
Exactly. Yvonne is the output. The output is the name of the biological mother. So I'm telling you here that the name of my mom is actually Yvonne. That's really what this interpretation means. So this is the output that corresponds to Norma. So F of Norma Elias equal Yvonne. This means that the name of Norma's mom is actually true, is Yvonne. That's the name of my mom. And that's really the notation that we are going to use. All right, one more example along the same line, actually a lot of examples. Some numeric and some not numeric. Okay, are you guys done? Can I move? All right, now one more example. Let that be the following rule, that assign to each number. So my input are number, even though I didn't write explicitly. So it takes each number. So it's assigned to each number the number 3. So my input values are number in this case. And my rule, take every number to the number 3. So question number 1 is f a function. Please, a lot of you don't have your faces. I really would like your faces. I mean, turn your camera on. Okay. I always give you a minute to interact with the problem and then ask me, is this rule? Okay. I'm going to pick one of you. Adriana. Remember, I don't know you. So when I pick somebody, I'm not picking on them. It's in front of me. Adriana, what's your input? Okay, we move to somebody else. Alicia Page.
Hello.
Hi, go ahead. Who is it? Adriana, Alicia, I don't know which I'm talking to.
This is Alicia.
Okay, Alicia, please, what do you think?
I'm actually kind of confused.
With what? Let's understand it. Help me out. We're going to work it together. What does this rule do? Let's read. Assign to each number number 3. Let's understand it. What do I mean? It takes, 1 is a number. What does it assign to it?
3.
3. Very good. A half is a number, right?
Yeah.
What does it assign to it?
3.
3. 4 is a number. What does it assign to it?
3.
3. But to every number, it's going to assign 3. Do you think it satisfies the condition of a function? Let's go back to it. Does it assign? So the input values are those numbers. I cannot really list all of them because there are a lot of them. So my input values are every possible number that you can think of. So the input values are all possible numbers, everything. And I'm assigning to each one of them E. So my question, is it a function? What does it mean? It means, am I assigning exactly one element to each input or more than one? What do you think, Alicia?
More than 1.
Why? What am I assigning to 1? How many numbers?
Oh, yeah, I'm sorry. So
that's okay. That's why I gave this example, so you guys get confused. Don't worry.
So each input has 1 output, but the output doesn't have more than 1.
Every input has 1.
Yeah.
I'm not assigning a bunch of numbers to 1. I'm assigning 3. That's okay. I can assign to a lot of input. I can assign the same thing. That's fine with that. But what I can't do is assign 2 things to 1. That's not a function. Are you with me?
Yeah.
But assigning a unique number, exactly 1, then I have a function. So is this a function? The answer is yes, because to every input, we're assigning exactly 1 output. Even though it's the same for all of them, it doesn't really matter, but I'm assigning exactly 1. There is no ambiguity in my assignment. That's really the idea. So is this a function? The function, yes, it is a function because
Are
Where
you
is
still
sign?
asking me?
Finish my sentence.
Because the input. How do I put this into
That's
words?
okay.
I understand what you're saying.
Yeah, it is a function because we're assigning exactly one output to every input. We're
Okay.
assigning exactly one output, namely 3 to each input. Okay, so here the input values are all possible numbers. Where did I get this from? Because I tell you the rule that is assigned to each number. So it means my input are every possible number, which infinitely many of them. I cannot really list them. And it is a function because we're assigning exactly one output to each input. So for example, so now let us use the function notation. What is f of 1? Somebody else beside Alicia who would like to take it over.
Again.
Go ahead.
Would it be
What?
3?
Exactly, it's 3. What is f of 10?
3.
3. Sorry, I have to mute all because you mute when you need to talk. It's equal to 3. F of, I don't know, 1/3. 1/3 is a number. I'm not telling you only 1, 2, 3. It's 3. No matter what you give it, you get 3. So the input is varying. So one way we can rewrite this function in a simpler way, I can say, suppose the following. If I call x, if x is a symbol for a number, then f of x is equal to what in this particular scenario? So if I use x as a symbol that represents every number, what is f of x?
It's still 3.
It's still 3. Absolutely correct. Okay, so when I tell you let f be a function given by f of x equal to 3, it means I have a rule that if you give it an x, this rule will give you 3. Regardless what x is, this rule will give you 3. So another example of a function. As I said today, the whole day we'll be working with the same idea actually. So what I want you to do now is the following. We're gonna do some worksheet together. And the way I would like you to do it is as follows. I want you to go to Brightspace because you will be doing that a lot this semester. Go to Brightspace and there is a module called Worksheet. Are you with me? Please, I want all of you to do that. Did you find it? Did you guys find it? I want a yes or a no.
Yes.
Yeah.
Yes.
I did not find it, no.
Yes.
It is on Brightspace under a module called Worksheet. Click on the module. Okay, and open it.
There's a module.
Yes, there is a module called Worksheet.
Worksheet.
Did you guys find it?
Yes.
Yes.
Yeah, I
Yes.
found it.
Very good.
Yes.
Because you're going to be doing that several times. So I want you to get used to that. All right. And we're going to be working on this worksheet together the rest of the time for today. Right. So since you have it, so if you don't see very clearly here, because I know previously the student had hard time reading that, I'm going to read it with you. We're going to understand it very well. And then we're going to answer the question. Are you with me? All right. 100 people are in a line. So already I want you to imagine a picture in your head. So you have people waiting in line. They want to buy a ticket for a rock concert.
Yes.
Let A be the set of integers from 1 to 100. In other words, A is a set, 1, 2, 3, up to 100. So I have the set A. So I'm drawing the picture. So I have a bunch of people standing in a line. I have 100 of them. So I'm drawing the picture to help us out, etc. We have 100. And one is represent this person, the one who's standing in line, 2, 3, up to 100. Okay, so 1, 2, 3. This is my set A. And let f be the following function. Okay, let f be the function that to each number in A, I call it m, to each number in A, so 1, 2, those are the number in A. M is a symbol that represents the numbers. Assign the first name of the person who is the mth person in the line. So what f does? To 1, so these are the input value because to each element in A, it's going to assign, so that's what f does. That's what f doing. To 1 is going to assign the first name of first person in line. First person in line. So I'm trying to explain what f does. To 2, so it's a rule. It's a rule. And what is doing? The first name of the second person in line. In line. And so on and so forth. So my input value here are 1, 2, 3, up to 100. Those are my input. And the way the function does, to 1, the first name of the first person in line, name of the second person, and so on and so forth. Okay, so that's how it works. Now, here's my question. Answer the following questions, explain completely. What does f of 1 tell you? So f of 1 will tell you what? Now, I try to explain it to you because that's the first time you see it. What does f of 1 tell you? What do you think the answer should be?
It's the name of the first person in line.
Exactly. F of 1 is the name of the first person in line. Okay, so f of 1 is the name of the first person online. The goal of those problems is to make us understand the rule. Make us understand it's the name of first person in line. Okay, 1 is the input. And my input here are 1, 2, 3 up to 100. F of 1 is what we are assigning to 1. That's the output. And what we're assigning to 1 is the name of the first person. Very good. What does f of 100 tell you?
The 100th person on the line.
Be very more precise.
It assigns to the 100th person
It's-
in the line.
It's the name. That's what I want. Because, yeah, it's the name, actually. It's the first name, to be more exact. It's the first name of the 100th person or the last person, if you want. Or the last, because there are only 100 people. Very good. Now we keep going. What is f of 20? So let us read here. Let us suppose John is the 20th person in the line and Sally is standing somewhere near the middle. That's what's given to us. So what is f of 20?
First name of the 20th person.
Okay, let's be more exact.
It would be John because it
Right.
says that John is the 20th person.
Absolutely correct. It is equal to John. Why it is equal to John? As your classmate said, the problem tells me that the 20th spot, the name of this kid here is John. So f of 20, which is the name of the person 20th in line, that's John. So f of 20 is John. So 20 is the input, which are where you are in the line, the first, the second. F of 20 is the first name of the person who's in the 20th spot. Right, D. It's a little bit harder, but we can get it. We know that Sally, if we go back to the problem, Sally is somewhere in the middle. So she could be the 60th, she could be the 40th, somewhere in the middle right there. And here is the problem. Suppose Sally is the nth person in the line. So somewhere there. What does f of the quantity n plus 2 tell you? I want you to think a little bit about it. Sally is somewhere here. So what does f of n plus 2? I'll let you think about it before we discuss it. All right, who has any idea?
Is it that like whatever position she is in line, she'll be, or whatever position in is, she'll be 2 positions behind that?
You're using she a little bit too much, which make it confusing. Try to be a little bit more precise.
Oh, wherever Sally is, I guess like that's 2 positions after the number given. So whatever n is, that'll be 2 positions after that.
So f of n plus 2 would be represent what?
9 plus 2.
Would it represent the person that is 2 people ahead of Sally?
Yeah, it's the name of the person. Now, is it 2 spots ahead or 2 spots behind? Let us analyze this.
It would be 2 spots ahead, right? Because it's plus, so she's in front of her.
Yeah, so
Right.
the person should be behind Sally in the line.
Oh.
Let us think about it. Let us think about it. So all of you figure it out. Let us say that, let us assume, just let's suppose that Sally is in the 60th position. All right? So n here equal to 60. So f of 60, so that's an example, so I understand the general situation. So f of 60 in my scenario is Sally. You guys understand what I wrote here? Please, if you don't, let me know. So if I am on the line 1, 2, 3, 4, 5, 6, on the 60th position, let us say Sally. That's where Sally is. So the question is, what does f of n plus 2? It means f of 62. It would represent what? So this is 61, this 62. So f of 62 is going to represent the name of the person, which is right there. So if we think about the line, it's the name of the person which is 2 spots behind Sally in the line. I stop and ask you a question. Were you able to follow, yes or not? Any questions? Okay, so if let us say Sally is here, f of n plus 2 is going to be the name of the person. That's an output value. It's the first name of the person that is 2 spots behind Sally, because n plus 2 is going to be behind Sally. So f n plus 2 is the name of the person that is 2 spots behind Sally. Or 2 places, wherever you want, behind Sally. So first, it's in name, because I'm asking for an output. It's in name, so the object is in name, but the name of who? The name of the person that is a little bit behind Sally. How much a little bit? 2 spots behind Sally. Now E. E should be easy. Suppose Sally is the nth person in the line. What does f of n minus 2 tell you? So that's an output value. What does it tell you?
It would be the
Person.
name of the person that's 2 in front of Sally, 2
Right.
spots in.
Yeah, because if you go
So
back,
Sally's 60.
right,
she would
if you
be-
go back here, if n Sally is in the 60th position, minus 2, it means I'm asking about f of n minus 2 would tell me the name of the person which is right there. That's what f of n minus 2. So it's going to be the name of the person that is 2 spots ahead of Sally. So it's an example of where my input here are the numbers, and my output is the name of the person who is in the given position. Right. Now we're gonna move to number 2. First, do you have any questions before I move on? Any question? Please ask so you can understand. So let me ask you a very simple question. Suppose I am working with the same problem and I write something like that. F of 15 equal amber. Okay? Interpret the sentence for me.
Would it be the name of the 15th person in line is Amber?
Exactly. That's really what it means. F of 15 equal to amber mean the name of the person that's 15th in line is Amber. This is the input is where we are in the line. That's the 15th position. F of it is the name of the person which is in the 15th position. So the input is the position. The output is the name of the given person in that position. So that's how the rule is defined. Very good. Let's move to number 2. Again, all of those, we're going to work them together. Let's move to number 2. And we read it and we try to understand it. Right. Let A be the set of all citizens of the United States. So we know what A is, every citizen. And F is the following rule. F is the function that assigns to each citizen the number of letters in their first name. So that's the rule. So we input, so it's assigned to each citizen. So these are my input. The citizen are my input, and it's assigned to them. So if I want to think about it as a rule, it takes the citizen. So this is the citizen. It's going to assign to it the number of letters in the first name. Number of letters in first name. Okay, so my input value, my inputs are the US citizen. Those are my input. And to each one of them, they're going to assign the number of letters in the first name. Okay. So before we even answer the question, so let us basically understand the function. So suppose I input, I'm a US citizen, despite my accent, but I am a US citizen. So suppose I input Norma Elias. What will F output for me? Okay, back to you. If I input Norma Elias, I'm trying to understand the function before we answer the question. If I input Norma Elias, what the F should spit out?
5.
5. So f of Norma Elias is equal to 5. That's the number of letters in my first name. If I input Amanda, let's assume Amanda is a US citizen, f of Amanda is the number of letters in the word Amanda, which is 1, 2, 3, 4, 5, 6. So that's what f is doing. Now I'm going to go back to the question, and for each item below, indicate the type of object that the item, for example, the item in number, the item in name, is the item a person? So, hey, what type of object is f of c? So if I take f of c, what type of object this is? So this is kind of confusing. So let me a little bit clarify. If I write f of c, the c here is a symbol for what?
A US citizen
Absolutely.
or a citizen. Yeah.
C is a symbol for US citizen because my function is associating to every citizen the number of letters. So let's go inside. This C here is a symbol for any US citizen. So we have really to understand the symbolism here. So C, it means what's inside the parentheses. So C is, let me write it down. C is the symbol for US citizen, which is a variable because the CSU citizen is US citizen. So it's absolutely a variable because the US citizen changes, and C represents a symbol for US citizen. But that's not the question. The question is, what type of object is f of c? It means the whole thing, f of c. What type of object it is? Is it a number? Is it a name? Is it a person? Back to you. Think a little bit. What is f of c? I try to give you an example to help you out in here. Means when I evaluate f of c, what should I get? Do I get a number? Do I get, I don't know, a person? What do I get?
You get a number?
Absolutely a number. Because f of c is what?
So C is a number.
Number of citizens.
Exactly. No, number of, be very precise.
Of the letters in their name.
Yes, it's the number of letters in their name. So f of c is a number because that's an output value. So c is a name. C is a citizen, which is a name of a citizen. F of c is output. So f of c is the number. It's a number of the letter in the first name. Letters in the first name of C. So C, which is inside the parenthesis, is a symbol for US citizen, but the output is a number. Okay. All right. Now, part B. Again, you guys have everything. Part B. Let's read it. If f of c equal to d. So I know that there is a lot of letters in those homework, but I think they are crucial for us to understand. If f of c equal to d, what type of object is c? Is it a number? Is it a word? Is it what type of object? It's the same function. We're talking about the same rule that assign to every US citizen the number of letters in their first name. So if f of c equal to d, what type of object is c?
A name?
What?
Is it a name?
Name of what?
The U.S. citizen.
Right. C represent the name of a U.S. citizen because C is what here? Is it in, C here is an input value, right? That's what goes into the parentheses. I don't know why there is noise today. I've never had that issue before. Okay, C is an input value. So the C here, the C is represent the name, if you want, of a U.S. citizen. Okay, that's the input value. What about the D in this picture? Even though the question doesn't ask about D, but I want to ask you about D. What does D represent in the picture? Always remember, what's F doing? What is F doing? What it does? To US citizen, it associates the number of letters in the first name. So as long as you keep track with what F is doing, we understand that. So here's my question is, what is D in this issue? Is it a number? Is it a letter? What is this? Back to you.
Would it be a number? The number of letters in the person's
Yes.
name?
Right, because is it an input or an output value? The D in this particular problem.
Input?
Output.
Output.
Oh.
What's the input here?
The F of C.
No. The input is what's inside your parentheses. C. That's your input. F of C, this whole thing, is what you assign to C, which is an output value. So I repeat one more time. The C, what goes into the parentheses, that's the input value. So the C is this piece. It's right there in the picture. It's what you give the function. And the rule, F of C, is what you assign to C, the number of letters. This is the output value. So F of C is what you assign to C. That's the output value. What is it you're assigning to it? That's what F of C here. So D is F of C. It means D is what you assign to C. What you assign to C is a number. It's the number of letters in the first name of C. So that's really what the picture is. So what goes in here is your input. It means the thing you assign something to. That's what goes inside the parentheses. F of C is the thing you assign to it, which is your output value. So here to the US citizen, these are my input values, I'm assigning the number of letters. So D is F of C, it means the number of letters in the name. Okay, is the time up or? I think so. All right, I was hoping to finish number 3 with you, but okay, the time is up. Yeah, thank you. So.
Thank you.
All right, so what is it? You guys ask a lot of questions. No, the worksheet are not to hand it in. The worksheet are something we work on it in class, so you guys can do your homework and understand the material. Is that clear? So every time you will have some kind of worksheet to help you through the material. For Thursday, what I'm expecting from you is, I already put the homework on Blackboard and it's a practice problem. Those are not truly to hand in. You do them, and on Thursday you ask me questions. What is it you are not able to do? And we discuss it. Okay, have a great semester and see you on Thursday. All right, bye-bye, guys.
Yep.
Also, have any question, you guys can stay.
Thank you.
Thank you. Stay safe.
You too. You too. I am trying. You guys do it.
Have a good
Hello?
one. Take it easy.
The question isn't about math, but you made mention of your accent earlier. Where are you from?
Guess.
I was gonna say Austria.
Italy.
Italy. Why everybody say Italy?
Yo, get out of my room, bro.
No. I'm not from Italy. I'm from Lebanon. Do you know where this is?
You speak French?
I do speak French, definitely so. Yes, I do. It's my
I
second
speak French
language.
as well.
What?
I speak French as well.
You speak French yourself?
Yeah, I'm from France.
Hola.
No, hola is not French. That's Spanish. It's bonjour. 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 Okay.
Yeah, bonjour, bonjour.
Have a nice day.
You too. Bye-bye, guys. If you have any questions, let me know.
I have a question.
Please go ahead.
So would you be posting these Zoom meetings on
Yes, I will.
Brightspace?
But today,
Okay.
part of it would be, honestly, I forgot to start the recording. So the beginning, because I don't want your faces to show on YouTube. So I said I will not record the beginning when your faces are showing. But then I forgot to click it when I started the lecture. So
Professor, I noticed that it does say that it's recording on the top left.
right. So the first, I think only the first 20 minutes will not be. But after that, it will be recorded. Okay, so I am gonna put on Brightspace everything I recorded, which is most of the lecture, except the first beginning, because I didn't want your faces to show up. That's the only reason.
All right, thank you.
Only the first. Next time, it's gonna start recording automatically, and I think I should stop recording.